Long before dinosaurs ruled the Earth, the ancestors of mammals had their own age of dominance. These were the Synapsids, the ancient lineage that came before the dinosaurs and carried the first versions of many traits that would eventually define mammals. During the Permian period, the supercontinent of Pangaea was filled with them. Synapsids were not a side branch waiting for dinosaurs to arrive. They occupied many of the major roles on land: tusked herbivores, cropping vegetation, smaller forms digging into the ground, and saber-toothed predators built for killing large prey. For a long time, this was their world. But near the end of the Permian, a shadow was already moving over it: the Great Dying, the worst mass extinction in Earth's history. A crisis that would wipe out nearly 90% of species. Before that collapse, the Permian world belonged to Synapsids in a very visible way. Among the herbivores, dicynodonts were especially successful, with toothless, turtle-like beaks and, in many species, a pair of prominent tusks. Some, like the small Gachia, found safety underground. Others, like Udenodon, became large, robust animals, among the last giant synapsids of the late Permian. But Lystrosaurus had the kind of body that could survive a broken world. Low to the ground, powerfully built for digging, and able to feed on whatever remained. At the top of the food chain were the Gorgonopsids. Rubigea was powerfully built, with a massive skull and heavy proportions. Inostrancevia carried huge saber-like canines in a long predatory skull that looked unlike any mammalian carnivore alive today. This was the surface world before the Great Dying: tusked herbivores, heavy predators, burrowers, and synapsids filling roles that dinosaurs would only claim much later. But the coming collapse would not reward only the animals that looked powerful. Roughly 30 centimeters long, Galosaurus looked somewhat like a cross between an agile lizard and a modern ferret. It was an exceptional burrower, using its robust, flexible limbs to build underground shelters. Burrowing was more than a habit. It was protection. While larger animals faced the increasingly harsh surface, Galosaurus could retreat into the insulated, more stable world underground. That kind of shelter was about to matter more than ever. Then the world changed violently. Deep within what is now Siberia, colossal volcanic eruptions tore through the crust, releasing catastrophic volumes of carbon dioxide. This was not ordinary warming. In parts of the low-latitude world, temperatures may have climbed by around 8 to 10 degrees Celsius across the extinction interval, turning the tropics into places where large animals could barely function. The oceans changed in different ways at once. As the water warmed, it held less oxygen. Circulation weakened, oxygen-poor water spread, and entire marine communities began to collapse. On land, the damage moved through the food webs. Vegetation declined, water became harder to rely on, and the animals at the top of the system became especially vulnerable. Some large Gorgonopsians seemed to have disappeared even before the main boundary crisis. By the time the catastrophe had passed, the great saber-toothed synapsid predators were gone. Most of that dynasty disappeared, but the lineage did not. Somewhere among the survivors were the distant branches that would, much later, lead toward mammals. After the Great Dying, the synapsid story was no longer about ruling the land. It was about surviving it. In the ruins, survival favored a different kind of animal. The future belonged to the small, the adaptable, and the subterranean. As the Triassic period dawned, the age of reptiles began. But the synapsids were far from finished. In the immediate aftermath of the cataclysm, Lystrosaurus did something extraordinary. In some early Triassic fossil assemblages, it became overwhelmingly abundant, sometimes making up the vast majority of land vertebrate remains. It is one of the great survivors in the fossil record. While early archosaurs, the ancestors of crocodiles and dinosaurs, began to claim the land, surviving synapsids also pushed back toward large body sizes. Forms such as tetragonias foreshadowed a new group of giant dicynodonts called the Canamaioraiiforms. Soon, massive herbivores like Placerius and Ischigualastia became major animals in Triassic ecosystems. But as the Triassic progressed, a new rival appeared: the fast-growing, long-necked sauropodomorph dinosaurs. The giant dicynodonts began to fade, but they did not disappear quietly. In the late Triassic, Lysowickia reached elephant-like size, a final sign that dicynodonts could still produce giants even as dinosaurs were rising. The Therocephalians also pushed into the Triassic. Hardy predators like Moscorhinus and the specialized agile Oliverasuchus hunted in the early Triassic valleys. A subgroup known as the Bauroidea proved especially resilient, becoming the only Therocephalians to make it into the Middle Triassic. Among them were Tetrasynodon, with its specialized elongated snout, the short-tailed, surprisingly mammal-like Regisaurus, and Microgomphidon, one of the last Therocephalians. But the cynodont lineage matters most to us because it eventually led toward mammals. Galosaurus, having survived the Permian boundary, walked right into the Triassic. Soon after, Thrinaxodon appeared, a small, adaptable burrower and one of the clearest examples of post-extinction recovery. Triassic cynodonts diversified into predators, herbivores, and increasingly mammal-like forms. There were fierce predators like Cynognathus, which grew to the size of a pit bull, and specialized herbivores like Exaretodon. Some even evolved a strange type of armor. Protuberum developed bizarre, flattened neural spines on its back, and ribs reinforced with bony subcutaneous nodules, likely offering protection against increasingly aggressive archosaurs. But while some cynodonts became large, others moved in the opposite direction. An advanced group called the Probinognathia appeared in the Middle Triassic, marking a major trend toward miniaturization. Probinognathus refined the jaw joint, bringing it closer to the mammalian condition. By the Carnian age, Prosostrodon displayed a skeleton and gait close to the condition seen in the earliest mammalia forms. These small, agile animals survived the intense climatic shifts of the Carnian pluvial event, adapting to forage at night while reptiles dominated much of the day. Near the end of the Triassic, we find Adelobasileus. Discovered in North America, far from the southern lands of Gondwana, where many related forms are better known, this tiny animal preserves an important clue. Inside its fossilized skull, the region associated with the cochlea, the inner ear organ responsible for hearing, shows transitional changes. Adelobasileus sits close to the shift from non-mammalian cynodonts toward true mammalia forms, preserving skull features that help reveal how that transformation happened. Out of this long line of survivors came Morganucodon. As dinosaurs rose around them, Morganucodon and its relatives survived at small body sizes, with high metabolism and a warm-blooded lifestyle. They moved through a world where being small could be an advantage, feeding on insects, relying on sharp hearing and smell, and carrying an insulating coat of fur. When you look back at the Triassic, It is easy to focus only on the rise of the dinosaurs. But beneath that story, another one was still moving. In burrows, in shadows, and under the ferns, the synapsid survivors were changing into something new. They were not an evolutionary dead end. They were the line that led to us.